Okay, welcome to our fourth podcast for covalent bonding. Today we're going to talk about polarity, both bond and molecular polarity. Okay, when you think about polarity, think about a magnet. It has a north pole and a south pole, and the more different the poles are, the more polar they are. Okay, in bonds and molecules, we can have a positive side and we can have a negative side. Okay, so let's take a look. Alright, so we can look at different types of bonding. The most polar material we have is an ionic bond, right? So here we have a crystal lattice for sodium chloride. We have actual positive sodium ions and negative chlorine ions with actual full positive and negative charges. So depending on what part of this molecule you touch, it's going to be either quite negative or quite positive. So the ionics are as polar as you can get. Then you have two different types of covalent bonds. You can have a polar covalent or a non-polar covalent. Let's actually start with the non-polar covalent. This would be if I have two atoms of the same element. Those atoms are going to share those electrons equally. They're going to have the same amount of pull. It's going to be a symmetrical bond. The electrons are going to spend about half the time on each side. As opposed to a polar covalent bond, which means that I've got two different poles. So let's say this is hydrogen chloride. Because chlorine is more electronegative, that means it's going to attract electrons to it better than the hydrogen will. So what that means is these electrons that they share are not going to be just sitting in between, but in fact they're going to spend more time closer to the chlorine side, making this side of the molecule more negative and this side more positive. Now this is not a full negative and positive charge like we have with ionic compounds, and that's why we use a delta symbol. It means it's more negative, more positive. Okay, so polar means different. We have a positive end and a negative end. Non-polar means not different. Okay, so we can look at bond polarity by using the electronegativity table on the last page of the packet. So remember, electronegativity is the tendency for an atom to be able to pull electrons towards itself when it's in a bond. And if you remember, fluorine is the highest electronegativity on the periodic table. It's got 7 valence electrons. It wants that 8th. It's going to pull very strongly on any electrons that it's in a bond with. And then electronegativity values decrease as you go to the left, and they decrease as you go down. But there's actual numbers that are assigned, and all of these numbers are compared to fluorine, which is set at about 4. So on the last page of your packet, you have this table. So we can actually do a calculation to see what the bond polarity is. So if I look at carbon, the value is here on the table. Let me pull up what mine is, and it says that carbon has an electronegativity of 2.55, and here we have CO2, right? And it's actually going to look like that. And the oxygen has an electronegativity value of 3.44, and if I subtract those, I'm going to end up with 0.89. So this is a polar bond. Okay, it has an electronegativity difference of 0.89. Okay, if I compare that to a bond, and I only have to look at one of these, I don't have to compare all 4 because they're all the same. If I compare carbon and chlorine, chlorine is 3.16, carbon is and carbon is 2.5. If I subtract these, I'm going to get, let me see, 0.61. So this is also polar, but not as polar as the carbon-oxygen bond. So this is polar. Okay, anything that starts with a metal is ionic, right? So this is ionic, and that's the only one that's ionic. Now, if I have something like FF, I've got 2 fluorines, 2 of the same atoms, pulling on the pair of electrons. They're going to pull equally, so this is going to be non-polar. So in general, anything that's not 2 atoms of the same element, it's going to be polar. but not all polars are exactly alike, so we can actually determine which one is most polar using electronegativity values. Okay, so at this point what I'd like you to do is stop and do the practice on page 9. You should pause the podcast, and when you're done with that, come on back. The answer key is in the middle. Okay, so here we can decide whether we have more polar bonds in one molecule than another. So I'm just going to draw. I've got carbon with 3 hydrogens in both cases. In one case it's chlorine, in the other case I have bromine. Everything else is the same, right? So if I want to know which molecule is polar, what makes the molecule polar is the fact that I have this bromine sticking out on one of them, chlorine on the other. So what I want to see is what's going to make it more negative, the bromine over here at 2.96 compared to the hydrogen at 2.1, or the chlorine at 3.16 compared to the hydrogen at 2.1. In both cases, the hydrogen sides are the same, and since the chlorine is greater, this will be a more polar, they're both polar molecules, but this will be more polar, okay, because the chlorine is more electronegative. Alright, so go ahead and do practice, and come back and answer the questions on page. Actually, before you do that, there's a 2-page packet on polar bears and penguins, which introduces you to the concept of molecular polarity. So you want to read that and then answer the questions on page 9 and then come on back.